Good morning, students, and most welcome in the chemistry class with the chapter Some Basic Concept of Chemistry. This is the chapter 1 of your syllabus. Students, previous day we have discussed the role of chemistry in our daily life, in the agricultural field, in the medical field, in industry, that we have seen chemistry has great role. And students, we have discussed many things about the chemistry, that is some basic concept of chemistry. Today, we will discuss the laws of chemical combination, and I discussed the previous day that is reactants converts to the products, and the formation of product is governed by different laws, like as laws of chemical combination, and laws of chemical combination. Just students, here A is the reactant and B is another reactant, and when A and B combine, the product AB is formed, and this formation of product is governed by different laws. And different laws. First law we have to study, law of conservation of mass. What is the law? According to this law, matter can neither be created nor be destroyed in a chemical reaction. And the statement is given by Antoine Lavoisier in the year 1743 to 1794. And according to this law, matter can neither be created nor be destroyed in a chemical reaction. Suppose sulfur plus iodine reacts and form products FeS, and the mass of sulfur and iron in the left hand side is equal to mass of FeS. If we take carbon and oxygen C plus O2, then the product is CO2. Carbon atomic mass is 12 gram, oxygen 16 gram, and 2 oxygen 32 gram. So carbon plus oxygen 44 gram, and carbon dioxide molar mass also 44 gram. So the formation of product means it will follow the law of conservation of mass, that never it will be the mass of product is more or less than mass of the reactants. Always the mass of reactants equal to mass of product, and this is the law of conservation of mass. So first law of chemical combination is the law of conservation of mass, that is mass can neither be created nor be destroyed, Sulfur 32 gram and iron is 56 gram, so 88 gram. 32 plus 56, 88 gram, and in the right side the product is given here. Its mass is also 88 grams, students. Now the second law we have to study, that is law of definite proportion. What is the law? Law of definite proportion. In a given compound always contains exactly the same proportion of the elements. In a given compound, element always contains exactly the same proportion of the element. Suppose in carbon dioxide, 3 gram carbon monoxide, 3 gram carbon and 4 gram oxygen. Carbon dioxide, 3 gram carbon and 8 gram oxygen. The compound 7 gram of carbon monoxide and here 11 gram of carbon dioxide. Oxygen to carbon mass ratio in carbon monoxide, that is 4/3 and here 8/3. Comparing to masses ratio, mass ratio for carbon dioxide is 2:1 and that is mass ratio of carbon dioxide, that is 2:1. So if we take another example of water, according to law of chemical combination, students, if we take water formula is H2O, hydrogen mass 1.008 gram, that is approximately 1 gram. So H2O means 2 gram hydrogen and 16 gram oxygen. So ratio is 1:8. My dear students, if we collect water from different sources like a river, pond and sea and analyze water in the laboratory, you will see that hydrogen and oxygen ratio always 1:8 in water. Never the ratio will be 2:5, 2:10. Always it will be 1:8. In carbon dioxide, carbon 12 gram, oxygen that is 32 gram. 12:32, that is 3:8. 12:32, that is 3:8. So 3:8 is the ratio of carbon and oxygen in carbon dioxide. Whatever the source of carbon dioxide, but always the ratio of carbon and oxygen is 3:8. So this is very, very important law of definite proportion. So again I'll repeat, what is the law of definite proportion? This law states that in a compound, the elements are fixed and elements combined in the fixed ratio of their mass. Like as water, hydrogen oxygen must be present and the ratio of hydrogen oxygen is 1:8. So this is the law of definite proportion. Now students, law of multiple proportion, and this law is given by John Dalton. If two elements can combine to form more than one compound, the masses of one element that combined with the fixed mass of the other elements are in the simple whole number ratio. Suppose here given examples, that is nitrogen and oxygen. Nitrogen and oxygen, that is NO. NO means nitric oxide, HNO3 nitric acid, and NO is the nitrogen monoxide or nitric oxide. Mass of nitrogen, mass of oxygen, that is nitrogen dioxide, NO and NO2. So I am telling you, if nitrogen and oxygen, if you take, the ratio of mass of nitrogen and oxygen is 14:16. But in nitrogen dioxide, 14:32. So 14 is the mass of nitrogen in both the compound. But the variable mass of oxygen in the two compounds, 16:32, that is 1:2. So what is the multiple proportion? Multiple proportions law like this: if two elements, in this compound, nitrogen and oxygen, two elements. If two elements can combine to form more than one compound, the masses of one element that combined with a fixed mass of the other element are in the simple whole number ratio. My dear students, if we take two elements, nitrogen and oxygen, and they form two compounds, NO and NO2, nitrogen monoxide and nitrogen dioxide, then the masses of one element, that is here oxygen, which combined with fixed mass of other element. The fixed mass of other element means it is nitrogen. So nitrogen mass is fixed in two compounds, but oxygen mass is variable in the two compounds. So according to the law of multiple proportion, the ratio of oxygen in two compounds, always simple whole number ratio, that is 16:32, that is 1:2. So this is the law of multiple proportion. Now students, Gay-Lussac's law of gases. Gay-Lussac's, G for gay, G for gas. According to this law, and Joseph Louis Gay-Lussac, that is stated that when gases combine and produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. One thing you keep it in mind that students, the Gay-Lussac's law is applicable when the reactants and products both are in the gaseous state. And according to this law, the ratio of the volume of the gaseous reactant and products at a particular temperature and pressure always bear the simple whole number ratio. If we take 1 mole of hydrogen gas H2, 1 mole of chlorine gas Cl2, then the product will be 2 liter of HCl, that is 1 liter of hydrogen gas. When reacts with 1 liter of chlorine gas, the product will be 2 liters of HCl gas. So this is the Gay-Lussac's law. If we take water formation, we can explain here also according to the Gay-Lussac's law. So when gas combines or are produced in a chemical reaction, they do so in simple ratio by volume, provided all gases are at same temperature and pressure. That is, temperature and pressure must be same. Temperature and pressure must be same. Then the product volume and the reactant volumes, which are in the gaseous state, always bears the simple whole number ratio. Next law, Avogadro's law. According to Avogadro's law, equal volume of gases contain equal number of molecules at standard temperature and pressure. Very, very important law. Equal volume of gases contains equal number of molecules at standard temperature and pressure. If we take 2 mole of hydrogen and 1 mole of oxygen, my dear students, you know 2 mole of water will be formed. 2H2 plus O2 equal to 2H2O. So equal volume of all gases contain equal number of molecules at standard temperature and pressure. Suppose if you take 1 liter of oxygen gas and 1 liter of carbon dioxide gas, and the oxygen gas and carbon dioxide gas at the standard temperature and pressure, then 1 liter of oxygen gas and 1 liter of carbon dioxide gas both have the equal number of molecules. And equal number of molecules, and the molecules number, Avogadro's number 6.022 into 10 to the power 23. If I tell you the number of water particles present in 18 gram of water, you know students, the molar mass of water is 18 gram, and 1 mole of any substance means its molar mass. So if I tell you what is the number of water particle present in 1 mole of water, your answer, ma'am, Avogadro's number. What is the value of Avogadro's number? You write in the notebook 6.022 into 23. So 1 mole of any substance contains the Avogadro's number of molecules. And this concept we have to use to solve the numericals. Gradually we will solve the numericals. So this is the Avogadro's law. Now students, Dalton's atomic theory. Dalton's atomic theory. Dalton's atomic theory, John Dalton in the right side, that is written about John Dalton. And according to the Dalton's atomic theory, matter consists of indivisible atoms. So first atom's definition given by John Dalton. And second is all the atoms of the given element have identical properties including identical mass. And next, third is the compounds are formed when atoms of different elements combine in the fixed ratio. And fourth, chemical reactions involve reorganization of atoms. These are neither created nor destroyed in a chemical reaction. So students, what are the Dalton's atomic theory? First is matter consists of indivisible particles, that is known as atom. Second, atoms of the elements are same in all the respects, and atoms of different elements are different in all the respects. But do you know students, this Dalton's atomic theory, this postulate was proved wrong when isotopes discovered. What is isotope? Isotopes are the atoms of the elements having same atomic number but different atomic mass. So when isotopes discovered, then the statement 2 was proved wrong, because you know that Isotopes means same atomic number but different mass number of the atoms of the same elements, and they are not same in all the respect. Compounds are formed when atoms of different elements combine in the fixed ratio. This is correct statement. And chemical reactions involve reorganization of atoms. These are neither created nor destroyed in a chemical reaction. Now students, we have to know atomic and molecular masses. Atomic mass, that is atomic mass unit. You know students, in standard 10 you have learned that is the atomic mass unit. It is the 1/12th of the mass of one atom of carbon atom. What do you mean by atomic mass of oxygen is 16 gram? Tell me students, what do you mean by atomic mass of oxygen is 16 gram? Yes, you are absolutely right. It means that one atom of oxygen is 16 times heavier than 1/12th of the mass of one atom of carbon 12. You know, students, carbon has different isotopes, C12 and C14. So, if we compare the atomic mass, if I tell what is the meaning of atomic mass of nitrogen is 14 gram, answer is, ma'am, one atom of nitrogen is 14 times heavier than 1/12 of the mass of one atom of C12. So you should know today AMU has been replaced by U, which is molar mass. Molar mass of oxygen near about 16 gram. Molar mass of hydrogen near about 1.008 gram per mole. Molar mass of water is 18.0153 gram per mole, but approximately we take it is 18 grams. Molar mass and formula mass. Molecular mass is the sum of atomic mass of the elements. You know students, water. Water means H2O. So what is the molecular mass of water? 18 gram. How? Because H2O, 2 hydrogen, 2 gram, 1 oxygen, 16 gram. So 16 plus 2 equal to 18 gram. In the right hand side, the calculating molecular weight is given here. That is hydrogen atoms and oxygen. So 18.0153 grams of water molecular mass here calculated. Just you see students, this is the water 18.01. How? 2 hydrogen atom 2.01588 gram, 1 oxygen atom 15.994 gram. So if you add hydrogen mass and oxygen mass, we get 18.0153 gram. Therefore, the molecular weight of water is this. Formula in mass is the empirical formula of the substance. Next is mole concept. Students, you know mole concept. What is mole? In standard 9, you have learnt the mole. What is mole? Mole is the Avogadro's number of particles. Suppose if I tell you what is the mass of 1 mole of water, to 18 gram. What is the mass of 1 mole of carbon atom? 12 gram. What is the mass of 1 mole of oxygen atoms? 16 gram. What is the mass of 1 mole of nitrogen atom? 14 gram. So 1 mole of any substance have the molar mass of that substance, and it contains the Avogadro's number of particle. My dear children, you can, when you will drink water, you ask to your mom, 1 mole of water, it means that mass of water, that is 18 gram. So 1 mole of water is equal to 18 gram of water is equal to 6.022 into 10 to the power 23 water particles. 1 mole of carbon dioxide gas, it means that 44 gram carbon dioxide is equal to 6.022 into 10 to the power 23 carbon dioxide particles. So 1 mole of atoms is equal to 6.022 into 10 to the power 23 entities. 1 mole of atom equal to these entities. The mass of 1 mole of substance in gram is called its molar mass. What is molar mass? The mass of 1 mole of substance in gram is called its molar mass. So volume of gas in 1 liter. Another thing, students, under STP, standard temperature and pressure, 0 degree Celsius and 1 bar pressure, this is known as the standard temperature pressure. 1 mole of any gas occupies a constant volume, that is 22.4 liter. 22.4 liter. This is very, very important things, 22.4 liter. So 1 mole of any substance, volume 22.4 liter at the STP, and 1 mole of any substance have the molar mass of the substance. So this is the relation of the mole, number of particles, amount of the substance, and volume of the substance. So 4 things you have to know. 1 mole of carbon dioxide gas at STP occupies 22.4 liters, and 1 mole of carbon dioxide gas have the molecular mass, that is 44 gram. 1 mole of carbon dioxide gas contains 6.022 into 10 to the power 23 carbon dioxide particle. So this relation you have to know, students. And next is the limiting reagent that we have to discuss. Limiting reagent. When any reaction is carried out, if the reactants are not present in the amounts as required by a balanced chemical reaction. Suppose if we take the 2 reactants A and B, limiting reagent means L for limiting, L for less. Suppose 2 reactants A and B react and form the product AB. A amount is less, that is the amount which is required, then it is less, and other reactant amount is excess. Then whatever the amount of other reactant, when the amount of A will be totally consumed, then the reaction will be stopped, whatever the amount of other reactant. So limiting reactant means the reactant used up first in the chemical reaction. And excess reagent means the reactant present in quantities greater than necessary to react with the quantity of the limiting reagent. So limiting reagent limits the reaction, that when it is totally consumed, then the reaction will be stopped, whatever the amount of the excess reagent. In such reaction, one reactant is in excess over the other. The reactant which is present in the lesser amount gets consumed after some time, and after that no further reaction takes place, whatever be the amount of the other reactant present. Hence the reactant gets consumed, limits the amount of the product formed. So in the limiting reagent, which type questions will come? First questions we will discuss that what is limiting reagent. So I discuss, students, limiting reagent is the reactant which used up first in the chemical reaction and which is present in less quantity than necessary, and other reactant present in excess amount. And numericals related the limiting reagent we have to do, and we will do it later, students. So students, up to this that we have discussed limiting reagent, and next day we will discuss the concentration in the solution, molarity, molality, mole fractions, ppm. We have already discussed in the class, but we will give this topic in the video. The next video we will give the concentration in the solution. So students, I want to recall what we have learned in this thing, that is limiting reagent. We have learned here mole concept. We have learned here molar mass and atomic mass. And another things we have learned in these chapters, that is the laws of different chemical combinations, like as law of definite proportion, law of conservation of mass, law of multiple proportion, Gay-Lussac's law, Dalton's law, Avogadro's law, that we have learned. So students, one by one you will make the notes and write in the notebook and everything you learned. So good day, students, and thank you for listening the video. Thank you.